This video is going to cover CVE 2020-1472. Microsoft named it the Netlogon Elevation of Privilege Vulnerability. I think the security researcher at Secura more aptly named it Instantly Become Domain Admin by Subverting Netlogon Cryptography. I thought that was a little bit more appropriate. Some references to some of the tools I'll be using are below. One tool developed by the researchers to test for the vulnerability, and then another tool to actually exploit the vulnerability, as well as Impacket's tool set to help along the way. This attack itself is relatively easy to pull off. The tool set is readily available, and it's not all that complex, as you'll see. If you're looking to skip over the boring talk about the vulnerability itself and get right into the how-to and the hacking, you want to jump to about the 4-minute mark. This is the Microsoft reference article for the CVE, CVSS score of 10.0. Updates to remediate came out August 11th. We're going to pop over to the actual Secura blog, where Tom Tavort covers what he actually did to instantly become a domain admin. We're going to hop over to his white paper and go into a little bit of detail here on the actual exploit. It's a relatively quick read to go through. He does make reference there to the testing tool that they published on GitHub. We will be using that. He identifies at a high level how the Netlogon protocol works, which is the protocol that is being exploited. The root of the issue is AES when used in block cipher mode CFB8. Under normal operation, AES CFB8 will take a given message and run it through the encryption process and produce an encrypted message out the other end. In this case, the article goes on to identify the fact that the compute netlogon credential function specifies that an initialization vector should always be 16 0 bytes. And that for 1 in every 256 keys, applying AES CFB8 encryption to an all-0 plain text input will result in an all-0 ciphertext. This leads us to our 5 steps to domain admin. Step 1 is spoofing the client credential. We can already do this because we know that for every 1 in 256 session keys, the correct client credential will also consist of 8 zeros. The second step is disabling signing and sealing. This is an optional step and can be disabled by not setting a flag in the server call. Step 3 is being able to spoof a call to the server. This is fairly simple at this point, since what the server looks for is an incrementing value compared to the client stored credential. Since our value is all zeros, the first call will be a 0 as well. There's also a timestamp element, but apparently the server doesn't really care much of what that's set to, so we just set that to 0 as well, which will be January 1st, 1970. Next is step 4, changing the computer's AD password. We can exploit a net server password set to call that will allow us to set the computer password, and Active Directory doesn't place any real restrictions on that, so you can set a blank password for a computer account. Final step in this process is going from the password change to obtaining domain admin. You can see the article gives a brief rundown of the protocol with a bunch of zeros set. Makes life easy for us. And then we will be leveraging Impacket's Secretsdump to dump the domain credentials and NTLM hashes for all accounts across the domain. First things first, we'll hop into our unpatched domain controller. Just going to give a brief overview of the setup here. Its name is DC01. I have logged in as the domain admin, and my IP is 192.168.20.10. Quickly run system info here and just give an overview of the patches that have been applied as a reference. One of the most recent patches here, KB 45.12.578. And if you do a quick Google on that, you'll see that the date of application is September 10th, 2019. So suffice to say, this domain controller has not been patched in quite some time. Moving over to our Kali instance, the attacking machine, the first thing you're gonna see me do is go through a little bit of a Windows setup here. So I sped this portion up just slightly. And now we're just gonna spend some time and grab a few repositories from GitHub that we're going to need. The first one we're going to use is the actual tool from that Secura blog for testing if a domain controller is vulnerable to this exploit or not. The second tool we're going to download is called Zerologon. That was the nickname for the exploit. This repository was not referenced in the article, but it was fairly reliable in terms of exploitation and is based on the Secura research. And finally, we're going to go download the most recent version of Impacket. Impacket does come with Kali, but the version that is installed and maintained on Kali is not up to date enough for the Zerologn exploit. And there we go. We've got our testing tool, CVE-2020-1472, our Zerologn exploit, and our updated Impacket repositories all set and ready to go. Now, I ran into some Python interdependency issues while I was trying to run the Impacket with the Zerologn and the testing tool. So what you're seeing me do here is set up a Python virtual environment so that I can separate this tool set from the rest of my Kali Linux system. I won't be going into much detail on this at all, so I'm just going to speed this section up a little bit here. With my virtual environment set up, you can see I'm pointing to a local instance of Python 3. And you can also see the packages that I have installed are fairly limited since it's a pretty clean environment. The first thing I wanted to do here was try to run Secretsdump, just to show that the domain controller by default is not susceptible to this exploit. You can see here I forgot to install the packages to be able to run Impacket in my local virtual environment, so I'm just going to get that out of the way. So let's try running Secretsdump again. And you can see we successfully can run the command. It's just a matter of figuring out what to do with it. So we're going to run it one more time with the flags and command as documented in the Netlogon vulnerability GitHub page. We're going to specify the domain controller and the IP address, and we're going to hit enter for a blank password, and you can see that it has failed. Next, we're going to hop into the testing tool developed by Secura. And let's just run that and see what it's expecting. So it's looking for the domain controller name and the domain controller IP. Pretty straightforward. So if we run that, you'll see it will brute force the authentication until it can verify that the domain controller is susceptible to compromise. The next thing we're going to do is actually run the Zerologn exploit against our domain controller. So you can see the script set empty password, it's expecting the same parameters, so a domain controller name and the domain controller IP address. It will do the exact same thing, except it will actually set the password to blank. And as you can see there, the domain controller will now have an empty string for its machine password. Now that we've got a blank password on our domain controller, we're going to try to run Impacket's Secretsdump again. So same thing as before, we're going to specify the domain controller and the IP address. We'll specify a blank password, and what you'll see is it will dump all of the hashes out and the administrator hash for the domain. So now that we have this hash, we can use it to authenticate against the domain as the administrator for that domain. I'm just going to copy and paste this into this window in case we need it later. Now we're going to use another Impacket tool, Wmiexec. It will, by default, if you don't specify a command, it will try to launch a semi-interactive shell against the target. So we're going to specify the username fox/administrator. Fox is the domain name and administrator is the account. At the domain controller 192.168.20.10, and we're going to just specify the domain administrator hash. Hit enter on that, and what you'll see is we have a shell to the domain controller. I'm logged on as Fox administrator. I am on DC01, and you can see the IP address 192.168.20.10. So the first thing we can do here is have a little bit of fun, and we'll just add a good guy account to the domain. We'll also make sure that that good guy is part of our domain admins group. And then we'll go ahead and launch an RDP session to connect to that domain controller as our newly created good guy domain admin. Specify the target IP, specify our target domain, our target user is good guy, and our password is password exclamation mark. And what you'll see when we launch that is an RDP session to our domain controller. Just do a little bit of poking around here. You can see the good guy user sitting in the user's organizational unit, and just look at the member of, and you can see that that user is a member of the domain admins. And we could also have some fun and disable the administrator account or reset the password. Sky's the limit at this point. So yeah, patch your systems. Just for fun, I went ahead and patched my domain controller to the most recent patch set, just to see what the tool would look like if it was run against a patched domain controller. So same thing as previous, just showing system info to show some of the most recent patches. Copy that KB, throw it into Google, and take a look when its release date was. And you can see November 10th, 2020 was that KB. So safe to say that this operating system is patched within reason. So same thing as before. I'm gonna hop over to our Kali box, our attacking machine, and run the Zerologon tester. And what you'll see, I'm gonna speed this up a little bit, is that this is gonna run through all 2,000 attempts, I believe, and it will fail. And you should get back a domain controller most likely patched message. There we go. Target is probably patched. Just to reiterate a fairly important and maybe overlooked point, just because your system is patched does not mean that passing that hash won't work. Once that hash is out in the open, it will work fairly consistently. So I can still log in as the administrator using that hash.